Hi everybody, my name is Anibal Azevedo and now we're gonna start the class number 4 of the third track about how we can apply artificial intelligence techniques to help to solve some problems, some operational problems in container ship terminals. So we made some developments in the previously class. So a card here will appear somewhere and what's the problem that we saw in the last class is how we can encode a series of combinations of rules in terms of numbers. So I will give you a better perspective of this problem now. So here we have the simulation that we made, and now imagine that we should apply some rules in port 1, in port 2, and port 3. So we can choose a rule for port 1 that's different of the rule that we apply in port 2. In fact, this number represents not a rule, but a combination of rules. For example, imagine that we are applying a loading rule in port 2 and unloading rule in the same port or in the port 3. So imagine that we are applying a certain combination of loading and unloading rules in this port 2, but we apply a different combination of rules in a different port. In this scheme that we described, in the code that we described, how we can perform a simulation, this is not possible because we should fix the name of the unloading rule and the name of loading rule inside this loop that will perform the application of unloading and loading rules for certain ports. So to avoid this fixed schema of loading and unloading rules, we should develop a special kind of encoding. So to do this, we need to understand another thing, and this thing will appear not very related with the subject, but it will be very important to create an efficient encoding. So imagine that we have this. Okay. So now I'm gonna present you this thing. Uh, and one will be math floor. Oh, it's not necessary at this moment. Okay, it's not necessary at this moment. So let's do it more simple. Imagine this. I believe this operator is not well understood, but it will be very important to your task to produce a very compact encoding. So what's this operator do? This is the rest of the integer division. So the variable will assume 0 value 1, 2, 3, 4 until we reach 35. Okay, but when I perform this, I saying that okay, take this integer value, divide by 3, and take the rest. So if I take the value 0 and divide by 3, the rest of this division will be 0. If I take, let's check this. To understand this, it will be helpful to see this, okay? Remember that all codes will be in the description of this video, okay? So if you have some difficulties to copy or to execute the code, you can get in the description of this video the code and copy or save in your Google Drive the code. So and then execute. Click here, okay? So if the variable value is 0, this another variable, the rest of the division by 3 will be 0. Or this value variable value is 1, and 2. Well, when this variable is equal to 3, the this variable is not will be not 3 because we are dividing by 3, and the rest of division of 3 divided by 3 is 0. 0. Look at here. So let's eliminate this. In fact, what we are doing, we are limiting the possibility, the possible variables. Made another bad thing here. Let's undo this. Okay, so now it's okay. Let's let's put all things in one line because this will be very useful for future uh, managing that we have one. So look at this now. Uh, Okay, I forgot to end. So it will be more interesting to see something, some patterns here. Okay, if the variable is 1, this will be 0, right? How we can fix this? We can add 1. And now the new variable will be, so let's change this name, it's not good. I can change it to J. Okay, it's more clear to see. So 1, we're gonna have 1, 2, 3, 4, 5, 6, 7 until we have 36. But our numbers here are just limited from 1 to 3. Okay, so why this is interesting? Imagine that we have a number 1. This can represent the loading rule or the unloading rule 1. If I have the number 2, I will have the unloading rule number 2. Oh, whoa, okay, it's interesting because if I use the number 1, this represent this number unloading rule. But why I'm repeating this? Because we can combine the unloading rule with loading rules. So if you have also unloading rules, what we should do, we have also to see this thing. Let's see this. I can take this variable, divide by 6, and sum 1. Let's see what's happened, okay? Just see. Okay, so I will use here a k variable, and we put the value just to see what happened. Okay, now what we are seeing here, we have this 1, 2, 3. It's okay. And finally, what we got here, it's a more interesting thing, is that this will be limited to 6. So imagine that we have a number 1. This will represent the rule number unloading rule 1 and loading rule 1. But here, if we have number 2, this is number 2 also. This is not good because we should keep this number 1, 1, 1, 1, 1 and change, because we will get the combination of 1, 2, 3 with 1, and then with 2. This here we should start 2. How we can get this effect? We have to know a trick. So what's the trick? We have to use this math.floor divided by 3.0, and after this we get the rest of this by 6 and sum by 1. Okay, so if we do this, let's see what's happened. So now you get this interesting effect. See that the number 1 corresponds to unloading rule 1, and loading rule 1, unloading rule 2, loading rule 1, unloading rule 3, loading 1 RAM. So all these numbers represents a possible combination of all three unloading rules and a specific loading rule. After this, we have this another combination, which is all possible unloading rules, but with another loading rule. One loading rule number 2, and number 3, and number 4, and number 4, 5, and number 6, and then we repeat all over again. So what we are imagining, okay, so this table, this is a kind of table, will make all possibilities of combination of unloading rules with loading rules. We have all combinations, but we just avoid to use these combinations, which will be very messy. We can just simplify it and use this index that we can translate in terms of unloading and loading rules. Now imagine that we have more possibilities. Imagine that we have more equipments, more agents in your port. So what we can do now, how many rules that we have for this equipment, the port. So what we should do is the following. Okay, we got this 18. Why 18? Because all combinations of between these rules, the previously rules, will be 18. So I have to combine these 18 rules with the next rule and divide not by 6 now, by 3, because I have just 3 rules for this equipment. Imagine that this is the third equipment. I have to combine all previously rules for previously equipments with the 3 rules for two of this equipment. For the second equipment, I have 6 rules, so I divide by 6. And also I here have only 3 rules for this equipment, so I just use this. So you can also apply, this will be more interesting to a generalized scheme. So this will be the number of rules for this equipment and all the rules from previously. So I don't have previously equipments here at this moment, so I divide by 1. Here I already have 3 rules for this equipment and 6 rules for this equipment. The all combinations for previously equipments will make 18 rules divided by 3, which is the number of rules for this equipment. So let's check what we get here. Is T equals to ein 3. So now let's check what we get. Okay, perfectly. Now we get here all the possible combinations in a very, very fast way of 3 equipments. The first unloading rules of the container shipping, loading rules for the container ship 6. Also here we can add, for example, the operation rules of the quay cranes. So this is important because we can use unloading rules for the container ship, loading rules for the container ship, and rules to move the quay cranes. Okay. So with this, it's not enough because we have an import problem. What's the problem? Because this is starting in 0. So imagine that we are not starting in 0. We have to start in 1 and finish in 37. How we can, if we apply this, this will bring us a little messy in your code. So how we can, why we should start in one? Imagine that we are in the port one. We should use one here, not zero. So one possibility is to use the variable p minus one, or just to adapt this variable to minus one, minus one, and okay, now we got this. So I believe that is not okay because we are adding one here. So by doing this, now it's correct. So we can start, not start in zero, but in one, and then we start in the right index and just made this adjustment to that will do a perfect mapping for all possible rules, all combination of rules. Okay. So what we can do this, we should use this kind of mathematical operation or mathematical equations to create rules. We can add this mathematical operation to produce uh, names. Which names? The names of the rules, unloading, loading rules. So I will show in the next video how you can produce some names using this. I don't know if I can produce this right now. It will be very interesting. I can produce this at this moment. Yeah, it will be very interesting. So so let's finish this. Not now. I will show in the next video because this video is gonna be very long and complex. So I don't believe that will be very interesting. So in the next video, I will show how you can combine these equations with letters, with strings, and can produce automatically the name of rules that will be applied according to a certain encoding. Very crazy. So I hope you find this video interesting and useful, and see you in the next video. Bye.